Hi everyone, and welcome back to another video of IGCSE Math Preparation Series. My name is Erfan, and today I'm gonna do some topicalized past year paper questions for you. The topic that I have selected is money and finance, and as you know, there are two formulas involved, the simple interest and compound interest. I hope you guys still remember that. And without any further ado, let's start. Question number one, Emily invests X dollar at a rate of 3% per year, simple interest. After 5 years, she has $20.10 interest. So find the value of X. So something that you should bear in mind, using the formula for simple interest just gives you the interest after a certain period of time. So this is the formula, PRT over 100. So P is the principal, that is this much, X. And this is basically the rate, that is R. T is the time after 5 years. And the interest is here $20.10. So in some questions, they give you the total amount in the bank account. So you have to deduct the principal from it just to get the interest. So be careful. On the left-hand side, we only have to place the value of simple interest. So P is X times R, 3 times 5 over 100. Therefore, X is 2010 divided by 15. So how much would that be? Okay, that's 134 US dollar. Easy question. Question number two, Abdul invested 240 US dollar when the rate of simple interest was R% per year. Okay, after M months, the interest was I dollar. Write down and simplify an expression for I in terms of N and R. Okay, so it's quite clear the formula that we have to use. Of course, it's the same formula I used for previous question. Now, instead of numerical values, we have a bunch of variables. The only numerical value we have is actually the principal, right? 240 US dollar. The rest is in terms of, they're expressed in form of variable. And the time here is quite tricky. The rate is per year, right? That's an annual rate. However, the M, the number of the period that he left his money in the bank was M months. So if you want to replace the M in this equation, you must make sure that the time matches with the interest rate. So interest rate is given in year, right? However, the number of times that the money was left in the bank account is given to us in month. So you have to convert it to year. How do you do that? Well, basically you divide M by 12, which is the number of months in a year. It's not really confusing. You can think of 6 months, for example. If I ask you 6 months is what portion of a year? If you convert it to year, well, you divide 6 by 12 and you tell me 6 months is half a year, right? Does that make sense? Or 3 months is a quarter of a year, right? That's a quarter. Why? Because you divide 3 by 12, that gives you a quarter. So same thing here, you just don't have a number that's given M months. So you divide it by 12. Now the unit is a match with the interest rates. Now you just go ahead and replace everything. So the interest is I is equal to P is 240, R is R, T is M over 12, and we have to multiply it, of course, by 100. We have 100 in the denominator. So what happens is I can cancel this guy with this guy. So I'm left with 20, right? And then this with this, that gives me 5. So the answer is I is equal to RM over 5, right? As simple as that. So just the conversion was a little bit challenging. Be very careful that the time is same unit. We use the same unit for time. Moving on to question number 3. Carol invests $6,250 at the rate of 2% per year, compound interest. So calculate the total amount. Okay, the time is also given. This is n is 3. So if you recall the formula for compound interest, it's actually, this is total money. That's the difference between compound interest and simple interest. So when you use this formula, that gives you the total money in the bank account. So, and raised to the power of n, of course. If they ask you how much was the interest, at the end you have to subtract that by P again, the principal that you have invested. But they just asking for total amount. So it's not really tricky. You just use the equation. P is 6,250, 1 plus 2 over 100, right? And raised to the power of 3 after 3 years. That would be equivalent to multiplying 6,250 by 1.02, right? 2% is 0.02. You add it with 1 and you get 1.02 raised to the power of 3. Now you can grab your calculator and start keying these values. Okay, that is 6,632 and 55 cents. That's how much is in the bank account now, right? So if the question was asking how much interest is added, you have to subtract this, the principal, from this, the total money in the account. So moving on to question number 4. I think this is, yeah, now we have to do what I just told you here in this question. We have to subtract that because they're asking for interest. We have 2 people, Alex and Chris. So they invested same amount of money for same period of time, but one of them, same interest rate, right? But one of them chose simple interest. The other one chose the compound interest. So what we have to do, so for simple interest, this is the compound interest. Here we have PRT divided by 100. Here we have P times 1 plus R over 100 raised to the power of n minus P. So this is the compound interest. This is the simple interest. Let's do the substitution. We get same principle for both, right? 200 times 2 times 2. That's the number of years divided by 100. So I believe that should be 8, right? 2 times 2 times 2, that's 8. So here we have, let's do the substitution here. We have 200 times 1.02, right? 2% is 0.02 raised to the power of 2, then minus 200. I believe this should be slightly more than 8, not much, because it's been just 2 years. So the difference become more if you leave the money in your bank account for more period of time. So it grows exponentially. So it's $8.08, right? So $8.08. This is just $8. All right. So we're not done yet because they said how much more Chris gets from the interest from the money he invested. So that's clear. It's 8 cents, right? So 8.08 minus 8, that is 8 cents. Moving on to question number 5. Hazel invests 1,800 for 7 years at, so let me highlight the most underlined, the most important information given in the question, the compound interest. Calculate how much interest she will receive after 7 years. Give your answer correct to nearest dollar. Okay, calculate how much interest she receives. So not the total, but interest. So if you use this formula, this gives you the total amount after n years, right? However, if you want just to know the interest, you have to subtract it by P, again, the principal. So let's do the substitution. That is 1,800 times 1 point, the interest is 1.5%, that is 0.15, right? Raised to the power of 7, and then minus 1,800 again. So let's see how much is that. That is 197 point, they said to the nearest dollar. So it's 0.7, which you rounded to 198 US dollar, nearest dollar. Okay, so I hope it was clear how you obtained 1.0115. If you can do it in one shot, maybe you write it here. R is 1.5 over 100. You can use your calculator for that. This should give you 0.015, and then you add it with 1. This is what you get. So now the last two questions that I selected for you guys, it's about exponential growth and exponential decay. The technique that I'm about to use, that's something that you're already familiar with. I use this for the chapter percentages as well. Basically, the quantity, the value was written here, and then you multiply it by 1. We use plus if it was the growth or increase. We use minus if it was the loss. And then we put the rate here, right? And then if we have a number of years or certain period of time, you also raise it to the power of n. So that's the idea. So basically, we're going to use the compound formula, but this time we might get a minus here as well. That's the case of depreciation or loss, because it's not always growth. It could be decaying as well. So in this case, we have 20,000 bacteria, right, in an experiment. So they're gonna, the number of them will be increased. The rate is 30% per hour. So the time is per hour. Work out the number of bacteria after 4 hours. So it means n here should be 4, right? When you want to raise it to the power, that power should be 4. So here I put the 20,000. Then you multiply it 1, since this is increase, that is plus. The rate is 30%, and that's it. So it's very similar to the compound interest formula, but we're using it for the exponential growth, we call it exponential growth or decay. Okay, so let's use our calculator. It's 20,000 times 1.3 raised to the power of 4, 57,122. Okay, after how many whole hours from the start of the experiment will the number of bacteria be greater than 1 million? So basically, the idea is this is 20,000 times 1, okay, 1.3 raised to the power of n, which n is unknown, this is n, is greater than 1 million. Okay, so greater than or equal. So basically we can use logarithm to solve this, but you don't learn logarithm in math. However, you will learn it in add math. So the question is that the only approach, is that the only method that we can use here? Well, no, we can still solve this question by multiplying 20,000 by 1.3 and with the help of our calculator. So each time you multiply 20,000 by 1.3, you count 1, right? You add 1 to the number of hours. So for now, 20,000 20,000 times 1.3, so that's 1 hour. So you press the equal button on your calculator, that is 26,000, right? So that is 1, and then you multiply it by 1.3 again, you press the equal button, that is 2, and then after that you keep pressing the equal button, and you also count and see the screen if we reach 1 million or not. So equal, that is 43k, 3, 4, 5, 6, 7, 8. So I'm at 8 and I have already reached 160,000. So one more time, 9, that's 200,000. 10, 11, 12, 13, 14, 15. Yes, and I'm at 1,023,717. So that is n is equal to 15. So there's no other choice for you guys because you haven't learned logarithm yet, and you won't learn it in IGCSE Math, only the advanced student, but still you should be able to do this manually. So again, I repeat, just multiply 20,000 by 1.3 and you keep doing that, right? You keep multiplying by 1.3, but each time you add 1 unit to n, and also keep an eye on the screen of your calculator to see if you reach 1 million or not. Once you reach 1 million or a number close to that, then you stop and you see how much is the value for n, as simple as that. Okay, so next question is exponential decay. That's the last question for today. The formula that we're going to use is same. So as you can see, that's the decrease, that's a decay. We have this value 12,400. That's the value of motorbike. Of course, after few years, the value drops by 15%. So that is 1 minus 15%. Why we use minus? Because that's decrease. Okay, so for decrease or loss, we use minus. For profit or increase, we use plus. And n, or the years, is given to us. Just double check. Yeah, and the unit is same, so we don't need to do any conversion, right? This is 3 years, and also the rate of decay is per year. So I don't need to make any change to that, and that's it. Let's key in these numbers into our calculator and see what it gives us. Let me just rewrite it this way as a decimal. I'm sorry, that's a minus, meaning which 0.85 raised to the power of 3. So times 0.85 raised to the power of 3, that is 7,615, and there's a 15 cent as well. That is the final answer. So be careful. This is not how much it's been decreased. If they ask how much it's been decreased, right now they're asking calculate the value of the motorbike after 3 years. So this is the answer. But if in part B, for example, they said how much it's been decreased, then you say 12,400 minus this guy right here, and that gives us the answer. So be very careful this question again directly give you the final value. So having said that, I think this is a good place to stop. I hope you guys enjoyed the video. Please leave a comment below, and don't forget to like and subscribe my videos. I'll see you guys in the future videos. Stay safe.